Good afternoon, guys. Today is the beautiful day of April 29th of 2020, and I'm here to go ahead and go over another math lesson for our virtual learning. So let's get started. Our title is Reading and Creating Dot Plots. Reading and creating dot plots, and again, is the beautiful day of April 29th of 2020. Excuse me, sorry. Okay, so we do have two objectives for today. We have two objectives. The first one is TEKS 4.9a. This one is represent data on a frequency table dot plot or stem and leaf plot marked with whole numbers and fractions. Okay, that is our first objective. Our next objective is TEKS 4.9b. Solve 1- and 2-step problems using data in whole number, decimal, and fraction form in a dot plot. Okay, so these two objectives go hand in hand. I'm sorry. We have 4.9a and 4.9b as our objectives. They go hand in hand. Why? Because we are already interpreting data, making sure we know how to read tables, how to make them, and we're going to show you different tables throughout this lesson. On this one, we're creating the dot plot. Okay, that is a table or a set of numbers that we can use together to form what we know as a dot plot, which is a number line with little dots all over it. But it still gives us information in a manner that it is set correctly. You'll see what I'm getting to. So moving on, we do have two languages of the discipline today. Do have two languages of the discipline today that we're going to be using. The first language of the discipline is obviously dot plot. A dot plot shows data along a number line Each dot above a point on the line represents one number in a data set. Okay? Sorry about that. I had to include my little Harry Potter magnet. That way my page is not flying away from the video. So a dot plot shows data along a number line. Each dot above a point on the line represents one number in a data set. So they will give us where we have they will give us a table with numbers. In this table, we will need to fix it into what we call a dot plot. Okay? So, for example, they can give us a table that talks about the average animal lifespan and it will be in years, right? So you can give us this table right here, and then it tells us a cow, well, the animal, of course, and its lifespan. A cow can live up to 10 years. A black bear can live up to 18 years. A wolf can live up to 10 years. A kangaroo can live up to 7 years. A deer 10 years. I will add 2 more down here. A chicken 8 years, and a fox 9 years. Okay, so this is our table, right? It is giving us I'm sorry, let me go ahead and move my camera. There we go. Sorry, this is our table. So it's giving us information, right? It's the data that we've collected or somebody has collected so we can form this dot plot. So they will give you a table like this. Now you have to set up a number line. Now, do I really want to set up a number line starting from 1 all the way to my biggest number? No. So that's a hint, okay? A hint. The number line can start with the smallest data number. Okay, so here looking at this data, what number should I start my number line in so I can start my dot plot? What number? So my smallest number is 7. So I will create a number line, and this is how my dot plot starts forming. Okay, my lowest number is a 7. So I can go ahead and start this number line at 7. Now I have to continue the number line until it reaches or goes past the biggest number in my table. So what's my biggest number? 18. So let's create a number line where it shows the biggest number in our table so we can have a correct set, our correct data. So we have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So I created this dot plot right here. I went above the number. That way we're able to dot everything correctly. So now I have my number line. It ends at 27, which is good, right? Because I have no number greater than 27. So now I look at my information here. Let me look at it. According to what a dot plot is, it shows the data along a number line. So we created a number line already. Each dot above a point on the line represents a number in a data set. So this is my data set. I need to put this information into this number line with dots. So let's go ahead and start. A cow lifespan is 10 years. So I go to the number 10 in my number line, and it's called a dot plot for this reason. I simply draw a little dot on top of the 10, signifying that this cow's lifespan is already here. Now, moving on, a black bear, 18. So I need to find 18 in my number line, 15, 16, 17, 18 right here, and I put a dot. So I already took over the lifespan of the bear right there. A wolf, 10 years. What do you think I will do? Draw a dot on top. So that shows that two animals have a lifespan of 10 years so far. Okay, kangaroo, 7 years. So I go over here, above the 7, I draw a dot. So an animal has a lifespan of 7 years. A deer, 10. So again, I go to number 10, I draw another dot on top of that number 10. Okay, following a chicken, which is 8, so 7, 8 is right here. So an animal has a lifespan of 8 years. And a fox, a 9, 7, 8, 9 right here. Now, do you see why it's called a dot plot? We have various dots representing data that we have collected before. Yes, if we were using a data plot, we cannot tell which animal it is, right? But it still gives us that data of knowing that an animal has a lifespan of 7, 8, 9 years. 3 animals have a lifespan of 10 years, and 1 animal has a lifespan of 18 years. Okay, so this is what a data plot looks like. Okay, so you will have a table, you will create a number line, and with the information in that table, you guys will go ahead and dot points on top of each number. Now, the fun doesn't stop there. We have one more language of the discipline, which is called an outlier. Okay, an outlier. An outlier is any number in the data set that is very different from the rest of the numbers. Okay, so looking at the word outlier itself, we can go ahead and break it down. Okay? Out and liar into 2 words. Out meaning away from everything else, and liar, it's lying. Okay? So you can think about it that way. An outlier is any number in a data set that is very different from the rest of the numbers. So now, let's go look back at this data set above here. Do we have a number that is out away from it, out away from any other numbers? It's very separated from the rest of the numbers. Any dot that looks alone, it's lying on its own away from everybody else. Yes, we have this one right here. Right? This is the one that is separated from all the other data. Right? Think of it as if the animals were gathering together here, but then we only have this animal being lonely over here. So the outlier is that number, that dot on the line, on your line graph, right? On your number line, I'm sorry, not line graph. On your number line that is away from all the other information. So that's what an outlier is. This right here will be my outlier. the number that's away from the rest of the information. Now, let's say if it would have more numbers, more dots close to this one, then no, this would not be an outlier. It would have to be a number that is separated well enough from the other data plots. Okay. Okay. So let's go ahead and jump into our guided practice. So we have already a dot plot given to us, and that's what you will be seeing in your independent practice later on today. You will be seeing dot plots already created, and you need to read the information, okay? So we know the title of this dot plot is called Giraffe's Height, and we know it's going to be in feet, okay? So starting with that information given, how many of these giraffes are 14 feet tall? So we want to know how many of these giraffes are 14 feet tall. So we go back and look at that dot plot. Let's go back and look at it. Look at the number 14. So right here, how many dots do I have above that one? 2. So that means that 2 giraffes are 14 feet tall. Ta-da! Simple. Just like that, okay? Next one. What is the most common height of these giraffes? So go back and look at that data. Do we have dots that is the most common that we can see, like, oh, this one repeats a lot? Well, 14 repeats 2, that has 2 giraffes. 15 has 3, 16 has 2, and 18 has 2. Okay, is there one that's different? 15, right? It looks like there's more giraffes with that common height. So 15 feet is the most common height for those giraffes. Now, why not 14, 16, and 18? Well, they do have more than one giraffe. Excuse me. But we're looking for one that repeats the most. That's what means most common. It means that there's more of those heights out there. So in this case, 15 takes the win. Okay, moving on. How tall is the tallest of these giraffes? So now we're going to be looking at the height, which was my highest number, 20. But do I have anything there? No. How about 19? No. So then I do have 2 giraffes on 18. So that tells me that 2 giraffes are tallest from the rest of these over here. So that means 18 is the tallest of the giraffes, 18 feet tall. And then the last one, is 18 feet an outlier? Explain. Now, looking at this one, it doesn't seem that it's too far away, right? We only have one number out. If it would have been over here on the 20s, then maybe, yes, it would have been an outlier. But it shares the same data as others, right? Other dots. It's relatively close. It's only skipped by 1. So no, it is not an outlier. Because it shows similar data from the other dots. Remember, outliers are usually alone on its own. So this one, it has 2 dots, so it wouldn't be considered an outlier. Okay? But now, does that mean that a dot plot needs to have an outlier all the time? No, it cannot. It does not mean that. So some dot plots will have an outlier and some others won't. Okay? And just a few hints, if a question were to ask you how many giraffes were used for this study, all you need to do is simply add all the dots on top. So in this case, 2, 5, 7, 8, 9. So that means that I had a total of 9 giraffes for this study. Again, 2, 5, 6, 7, 8, 9. So if we simply count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 giraffes. So if they were to ask you in a future question on your independent practice, how many animals, how many people, how many kids, how many dogs, whatever that they're using, were used for this study, simply add up all the dots for the dot plot that you created. Okay, let's go ahead and move on to our last question. This one says complete the dot plot. So on this one, we're going to go ahead and look closely. We're going to look closely at this table that we have here. So we can tell that the title of the table is called Length of Sandy's Pencils. So we're looking at Sandy's pencil. She seems that she has red, blue, green, purple, and orange. Those are her pencils, and she gives us the length of each one. Excuse me. So for the red, she gives us the length of it, which is 6 1/4. Blue, 5 1/4. Green, 6 3/4. Purple, 5 3/4. Orange, 6 3/4. So now, let's go ahead. We have a table here, right? We've done this before. I already created my number line. I set it up in order. I started with this one of the smallest numbers, so I figured since they were using 5, I could start with 5. And I figured since there was the biggest number here was 6, I created it from 5, in between 5 and 6 in fraction format. Okay? So now I'll need to go input the information here into my number line to create a dot plot. So let's start with red, 6 1/4. Let me go look for 6 1/4 right here. So I'm going to put a dot on top of 6 1/4. Blue, 5 1/4, right there. Green, 6 3/4 over here. Purple, 5 3/4. And orange, 6 3/4. Okay, so as you can see, it's a little bit scattered all over the place, but that is how we created this dot plot. Now, if it were to ask you, look at the table and tell me how many pencils were used. Again, 1, 2, 3, 4, 5. There were 5 pencils used. Now another question could be asked, which is the common length, of Sandy's pencils? So which one has a common one? 6 3/4. Do we have an outlier here? Well, no, not really, because all of them really show almost the same information. They're not that separate apart from each other, so in this case, there's no outlier. Okay? Now, if we were comparing this one into a frequency table like the one Ms. Gallardo went over, then it's somewhat similar because both the dot plot and the frequency table organize data. They give us a table, right? And we need to organize it. In this case, we organize it using a number line, while the frequency table, we create a table for it and create tally marks for that, right? A dot plot shows a picture of the data. That's the only difference. The dot plot basically shows a picture of how it looks. You can tell how it spreads, okay? The frequency table is just tally marks. So please make sure that when you're going over your information, you're understanding it, looking at carefully at what it's asking you to do, okay? For your independent practice today, I will only be uploading a PDF of the assignment because some of these questions will require you to draw. So your final product, you should answer everything on a separate sheet of paper, creating your own dot plots, and answering all the questions on a separate sheet of paper. So for today's lesson, I will only be providing the PDF, and you guys will go ahead and, on a separate sheet of paper, answer the questions for that independent practice, okay? With that said, guys, I hope you have a great rest of your day. Keep making good choices, keep staying healthy, keep staying inside and following your parents' rules, and remember, it's almost close to the end of the year. I want you guys pushing hard because you guys will become fabulous 5th graders. With that said, I miss you so much and I love you all. Thank you for following along on this video and hope this video helps. Have a great rest of your day. Bye-bye.